Okay, I hope that was a good break for everyone. And yeah, up next we have Oleg Lodygensky from iExec, who will be speaking on combining ZK proofs with oracles to provide confidential data to smart contracts. Oleg, everyone.
Thank you. Thank you. Okay, great. So my name is Oleg Lodygensky. I'm CTO of iExec Blockchain Technology, a company based in France where we develop products that permit to create, share, and monetize digital assets based on our twofold value proposition, governance, thanks to the blockchain, and privacy, thanks to confidential computing. And today we will focus on privacy, and I will present you two ways to create privacy-preserving oracles. So as you may all know, an oracle is a way to gather data, off-chain data outside of the blockchain, and to bring them on-chain. And the question here is, how can we bring on-chain private data, sensitive data, confidential data, while preserving confidentiality? So before we answer this question, before we see two workflows to do so, to write sensitive data on-chain while preserving their confidentiality, maybe we would like to know, to understand why we would like to do that. Why would we like to push some private and confidential data on-chain, where the blockchain is, by essence, of course, transparent and public? So there are a lot of different use cases. You can think of medical data processing, so that maybe you would be engaged to process some, to give some information of your own medical data, but I mean, without revealing the detail of your data. Maybe you don't want to reveal, I don't know, something like your blood pressure on-chain, because you could be afraid that an insurance company could modulate the price regarding to your blood pressure, for example. So there may be use cases where you would like to write on-chain a proof that you are well-being. I mean, your blood pressure is good, but not revealing the detail of your blood pressure. There are other use cases where a company would like to share some sensitive data to gain access to a new type of data without revealing their detail of their own business, for example. But merging different data from different, even competitors, could gain access to a new kind of information without revealing the detail of the competitive information of each company. And also, another use case we are working on is that KYC. I mean, identity check. So that usually people, maybe people don't want to share their information, their names, their I don't know, the color of their eyes or what they want. And not only, the question is not only if individuals would like to do that, because you can discuss that people usually, a lot of people think that they have nothing to hide, but hiding such information could help company which needs to make a KYC. This company must be GDPR compliant. So we could help being GDPR compliant by stocking on-chain some information that the KYC has been done without revealing any detailed information about the identity of the individual or the client or what they want. Something that is very funny, I always like to mention that a lot of people think they have nothing to hide, but if you think about it, nobody stores any information online about their own bank account. Nobody gives any detail of the bank account. They give detail about who they are, what holidays, where they go for their holiday, what cars they buy, or things like that. But nobody never display any detailed information of their bank account. And the notion of privacy is something that people don't, maybe are not aware about that, but people use privacy-preserving techniques every day. If you use your credit card, you never say, hey, here's my bank account, the detail, look what I earn, look what I have in my bank account. No, of course not, you don't do that. Nobody does that. The credit card permits to pretend, to prove that you can pay something without revealing any detail of your bank account. And this is the idea of privacy preserving. So even people who think who do display all detail of their life, never detail any information of their bank account, and they do that in their everyday life. So privacy preserving is finally something very popular, even if people don't realize they use such technology in their everyday life. So here we will see two workflow, two technology to write on-chain some sensitive information without revealing this information. We will detail how zero-knowledge proof works. And also I would like to show you the advantage of using not only ZK, but also confidential computing, and we'll see what are these two technologies. So ZK, in one word, is a way to compress computation. We can see we can make a parallel with compressing files. Okay, ZK is a way to compress computation and give a very small result somewhere that can prove that the computation has been taken. So off-chain, the ZK permit to process some data. And after, when the processing is done, ZK technology by itself permits to generate a proof that this computation has been done, and the proof is quite small and very easy to verify. In terms of CPU intensivity, it's very low. So we can write the proof, the ZK proof online, and we can check the proof online. And this check permits to certify that something has happened, but never revealed what happened off-chain. The thing there is that on-chain, you cannot have access to data source, but off-chain, the one who had access to the computation, of course, these people had access to the data source. This is the problem we saw. So we introduce confidential computing in this workflow, so that it is exactly the same. We keep we use the ZK proof, the ZK technology, but the off-chain computation occurs in an enclave. So I'm sorry, I left TEE and not CC, but TEE stands for Trust Execution Environment, which is the Intel SGX version of confidential computing finally. It's the same. There are different, we know 3 technologies that permit confidential computing. There is Intel SGX, there is AMD SCV, and ARM Trust. There are other ways to do confidential computing, but here we, at iExec, decided to use the Silicium versions of this technology. So what happened using confidential computing? We take the data source, we run the computation in an enclave, and in an enclave, nobody is able to see what happened there. An enclave is a kind of a vault in your CPU finally, and nobody, even the administrator of the machine, nobody can see what happened inside this vault. Okay, and at iExec, we permit to use this enclave in a decentralized manner, in a distributed manner, so that anybody who has an enclave can propose the hardware finally, and you can use it remotely. And at the end, the process of the confidential computing generates, here I use attestation. I prefer to separate proof and keep this word proof for zero knowledge. And for confidential computing, we prefer to use the word attestation. But finally, it's the same mechanism. We write on-chain something that proves that something happened. And here again, on-chain, you cannot have access to the data source. This is just not possible, just like in ZK. The difference here is that the off-chain part of the computing is also uses a technology that ensures that nobody had access to the data source, except the one who was able to process it. Okay, so finally, we have seen that both technologies, both workflow permit to compute data source off-chain to create a proof of this computation. And here, only the oracle, the confidential computing oracle, permit to keep the confidentiality of the input data. And today, we are working to fill this gap, so that at the end we want to run the ZK Oracle process and the generation of the proof of the ZK proof inside an enclave using the confidential computing facility. And this is our next step, and I hope we will finish soon. And that is all. Thank you very much. Any question?